Okay, so we took a little hiatus there because burnout's a real thing. And you film so much and then you're like, I'm done with this. And you can't do it for a while. It's hard to summon the motivation to get back. But here we are. Wanted to do a problem from the 2022 AMC 10B. I actually solved several more questions that just never got filmed because, yeah, needed a little break to recharge the batteries. And so I wanted to do this one. It's kind of a fun problem. There's a lot of little interesting things within it. Let's get started. The picture is not included in the original, just in case you're wondering. I just added it to save time during the explanation. So 2022 AMC 10B problem 22. It was also the 12B problem 21. Let S be the set of circles that are tangent to each of the three circles in the coordinate plane whose equations are center 0, 0, radius 2, center 0, 0, radius 8, that's these two right here, and center 5, 0, radius radical 3. Okay, so really quickly, you should have memorized the approximate values of radical 3 and radical 2. They're about 1.7 and 1.4. They just come up so often, it's nice to have a quick, handy, rough estimate of what they are. And we'll see maybe some application of that here in a minute. What is the sum of the areas of all the circles in S? So again, S is the set of circles that fit that criteria. It has to be tangent to all three. Okay, one thing that you can do here, and I'm just going to do a quick sketch to demonstrate this. One thing, you might be like, well, how can I fit one in? Most people can see this one right here, right? Let me just try and draw it in real quick. Looking straight on it might do a little bit better job. Okay, so that's not too bad right there. Okay, most people can see that there's going to be one like this, right? And so you might be like trying to focus, and what you're thinking initially is, let's do all three circles, because that's what it says. But if it's going to be tangent to all three, wouldn't it need to be tangent to at least two, right? And so which two would you choose to work with? And you might think these two, but the better choice is the centered one and the big one. And so if you think about it, there's only two possible radii that can occur. Let's look at what we're talking about. I'm just going to do a quick sketch of those two circles. So you're going to have a circle like this, right? This is the center one. If it's going to be tangent to both of these circles, there's only two ways it can lie. The first one's going to be sandwiched in between in the donut area, something like this. In such a case, we know that if we pass the center of this circle through the center of this circle, it will hit the point of tangency, which will be the center of the outer circle. Okay? So, why would this definitely be hitting here? Number one, if I take the center of this circle to the point of tangency, this came up a long time ago actually in an older video I did, and at the time I couldn't think of what it was. I think somebody had suggested in the comment what it was, and it made perfect sense, and I now use it all the time to explain this. So if you were that person, thank you for the suggestion on why that is. I mean, I probably would have figured it out eventually, but when I was filming, I couldn't think of it. If you think about it now, right, if you have a circle, there is, for any point of tangency, if you connect the radius to a point of tangency, you will always get 90 degrees, right? 90-degree relationship, okay? That's basic. But think about what that means about that point. There's only going to be one point, right? From this point here, the center of this circle, there is only one point on this line, right? If I just give a random point and a line connecting to it, there's only one point that's 90 degrees, that's perpendicular. This is a theorem. Through any line and a point not on the line, there is exactly one line perpendicular to the given line. Okay? So if we know that, then we also know this fact. Well, this point right here is on both this circle and this circle. And so therefore, it must be the exact same point of tangency for both, because there's not two lines that are doing that. And since the center of this circle and the big circle is the same, I know that if I just cover up this circle, right, and just look at the big circle, if I have that circle here, like this look right here, I know I have to pass it through the center because it's the radius that does it. And a radius has to pass through the center. So this one center to that point, 90 degrees. This one center to the exact same point, 90 degrees. Therefore, it must pass through the center. Otherwise, it would violate the theorem. This is the kind of reasoning that's important. It's difficult to find that kind of reasoning in modern textbooks, by the way. The older textbooks are a little bit better with introducing those kinds of thoughts. So anyhow, at least the ones that I've seen. Let's get back to what we're doing over here. We would then know that what is the radius of this circle here? Well, since this radius is 2 and the outer radius is 8, and I know we're hitting a point of tangency here, this distance here must be 6. That's a diameter though, so its radius would be 3. And that would be the radius of this one as well. So I know that if I come through here and I pass through the point of tangency, that's another fact too. When you connect centers of circles, a good idea in circle problems by the way, whenever you do that, it will pass through their point of tangency. Okay? And the reason for that's kind of obvious, I guess. You have a radius of 3 and a radius of 2, and you know that their distance from the centers is 5, so there's got to be the point of tangency, otherwise it wouldn't be 5. It'd be like you're going here, and that wouldn't be 5, right? So we've got that. Let's think here as well then. Now we just want to know how many of this prototype exist. How many of this type of circle that rests on the outside of this circle in the donut region? We're going to be able to rotate this around, correct? Like this circle could roll like a disc all around in here. Okay? So if it does that, you currently have one, this one right here. And how do you know, by the way, how do you know that it's going to be able to hit so that it passes through this point of tangency as well? Like we know it works for this one. We know this one works. How do we know it's going to hit the point of tangency here though? How could we reason that? Well, let's think about that too. If we look at this circle over here, again this is the miniature sketch, and I rotate this other outer circle with radius 3 over here. Since its radius is 3, this being the x-axis, right? Where is this point right here? Okay, you're at 0, 0. The radius is 3 from here. It would be right here at -5. -5. Right? Because the whole distance is 8. This must be 5. Now, where is this center? This center is at 5, 0. So then it would mean that the distance from here all the way to here, from the center of this circle all the way to that circle, that distance is 10. Okay, so your maximum distance away is 10 from the centers. When I put this circle down here, again, what is its radius? Its radius is 3. And so you're going to be coming, actually, it's going to get all the way to the exact same spot on this side. Its center would be this center. In other words, at some point, it'll be concentric with that circle, which would mean the minimum distance of their centers is 0. And there's no reason at all to think that as you rotate it around, it's not going to hit every distance in between. The distance between the centers of these circles will be a smooth curve. It's not going to jump. There's not going to be gaps. There's no asymptotes or something that it can't get across or jump, like a step graph or something like that. So because of that, we know it's going to hit here, this first one right here. There will come a point. What is this distance, by the way, right here, from the center of this circle? What is that distance? That distance would be, this is root 3, and this one has a radius of 3, so this distance would be 3 plus root 3. What is 3 plus root 3? It's about 4.7. So the center of the circle, when it's on this resting point, will be about 4.7 units from the center of this circle. And there will come a point when it's right there resting. Furthermore, we could also draw it here, right? Like this. I'm drawing from the side, so it's probably not as great looking of a circle. So at some point, it's also going to come down here, so it's hitting, still, it's rotating around, just moving it around. At some point, this bottom edge will also be here. Okay? And so when that happens, think about the center of the circle now, right? You're going over here to right here. Now you're passing through there. Okay, so then the distance is going to be, since its radius is 3, its distance away from the center, because that's root 3, would now be 3 minus root 3. And what is that distance? Well, 3 minus 1.7, it's approximately 1.3. And that's in our range of min and max distances. It's going to happen, right? So when its center lies there, we know that it's tangent down here as well. Again, from this circle center through that circle center to the point of tangency has to happen at some point. Okay, you're getting 2 right here. Doesn't it make sense you're also going to get 2 with the top of this one resting here and resting here? It's like basically this one mirror image down and this one kind of done the same thing. You're going to move it down a little bit so that about this point right here will now be right there. So how many such circles do we get with radius 3? We get 4. 2 above, 2 below. So then we've got 4 and the radius is 3, so the area is 9 pi times 4, 36 pi. Okay, so there's those 4. Now, what is the other kind of circle? What is the other kind of circle that you could have had in here, right? The other kind of circle would be one where it goes like this. Again, focus on the center circle, the 2 that they're concentric, okay? Now you want one that's going to go more like this. And for that one, again, this is y-axis right here, okay, let's say. You know that this is 2, you know that this is 2, and the whole distance is 8, so this part is 6. Okay, again, from the outer edge of this inner circle, the outer edge, all the way out, all the way, is always a distance of 6 from the origin. So you're going to know then that the radius or the diameter of the other circle that we're adding, the circle in the set of S, that diameter is 10, which means its radius is 5. Now, how do we know if this circle is going to, how it's going to intersect here with that one? Let's get rid of some of this stuff real quick. See if I can get rid of most of it at least. It's really hard to redraw in the middle of filming. So I will do my best to just quickly erase this and generate what we want. What we're looking for is going to look something a little bit like, let's see, maybe more like something like that. And so this is what we're looking for, and we know that from the center of this circle, right, if its radius is 5, okay, then think about it here too. If I pass this through here, I know that this distance right here is 2. And so this distance is 3. So actually, you could tell me that the center of our circle of this type, the center of that one, is going to be on another circle. It's going to rotate around like this. This is the center of all such circles of this type. All such circles of this type. And so you think about it, what is its maximum distance? Right? This is the center, keep in mind. This is not that circle. It's the center of that circle. So then this distance from here, where is this point? It's located at -3, 0. This is the center of this circle. Its distance is 3 units plus 5 units, 8. For this type, the maximum distance is 8. And the minimum distance is what? Well, again, let me stand up here without knocking over my microphone. This distance here is the center of the circle, keep in mind, right? So you're looking at a circle that in this case would be going something like this. Hard to draw this from this angle. Something like that. For that circle with radius, the center is here. Its radius is 5, right? The radius is 5 because this distance is 3, this distance is 2, and you'll know from here to here is 5. So this is going to be at +3, 0. So now what is its minimum distance from its center to this one center? That minimum distance is 2. So you're going to have every distance between their centers of 8 and 2. So what does the distance need to be, right? What does the distance need to be now? Let me get rid of this one. In order for it to be able to hit like right here. Again, this is a point of tangency. Meaning if I pass it through the center of this circle, it will have to hit the center of this circle. Wait, we probably should be going the other way around. Probably more like this kind of thing. It's very poor drawing, and I'm trying to draw from the side. So doing the best I can with what we got to work with. Let me just use my finger, it'll be easier. Get rid of all this stuff. So you're going to have from this center, there's going to be a point of tangency somewhere here, and it's going to be connecting to about right here. So this distance passing through the center of the circle would be what? If the whole radius is 5, that distance is 5 minus root 3. Why are we doing this? We're trying to establish that it definitely has a point where it will be tangent to this circle. Okay? So if its distance to the center is 5 minus root 3, we know that if we continued it out, for the same reason we justified earlier, it would hit the point of tangency. What is 5 minus root 3? 5 minus 1.7, approximately 3.3. Is that in our range? It is in our range. So at some point, you will be this distance from the center, and if you pass through the center, you would continue on to hit their point of tangency, their mutual point of tangency. So we know we get one like this, and think about it too. As I rotate it around, right, there's going to be another one here, like that. So you're going to get, when you're rotating this direction, you're going to get two circles of that nature. What do you think happens going the other direction? You're going to get two more circles up there for, again, just like this one, 4 circles, each with radius 5, each with area 25 pi. 4 times 25 pi will be 100 pi. And when you add those, you get E, which is the answer. Now, something else I want to add to this. Whenever you're doing problems, always think about perhaps different variations of things that could be done. So maybe after your test is over, you're going back to recap, you might want to come back to this. Here's a thought. Could you find the x value of the center of this circle right here? This one right here, the first one we drew, not this one, but the one that's coming down here. Could you find this x value? How could we find it? What if they altered the question to say, find the sum of all of the, I don't know, positive x values or x values in the 4th quadrant that are the centers of the circles in set S? Right? Just a slight variation. How could you find that x value? Well, let's think about it. We know the center, again, of this circle, that's this circle right here, the center of this circle lies on this dotted circle. Then that is x squared plus y squared equals 9. And we said earlier that the distance, this is the center, mind you, this is the center. I have to keep saying that because it's weird, right? Because you're thinking this is the circle, but no, this is the center of the circle, right? So you're going to have a point on this circle, its distance from where? From 5, 0. That distance is going to need to be 5 minus rad 3. So I'm going to need it's almost like another circle here, right? And this circle is going to go out like this, right? Outside the other circle. We don't care. We're just looking for it to exist, this point to exist. I need the distance between their centers to be 5 minus rad 3. And again, the reason for that is when you pass the center of the circle through this center, you hit a point of tangency, which is exactly root 3 away from this center. And the total radius of that circle that we're working with is total radius is 5. Okay? So then that would mean its distance from the center is, as we said, 5 minus root 3. But think about it. That, if you're a constant distance of 5 minus root 3 from 5, 0, that's a circle. That's what a circle is. It's the locus of points a given distance from a center. Okay? And that given distance is the radius. So this would be like the radius of another circle, right? One centered at 5, 0 with this radius. What would that look like? It would be x minus 5 squared plus y squared equals, square that, 25 minus 10 rad 3 plus 9. I'm sorry, plus 3. Thinking square root of 9, but yeah, just plus 3. Okay, so now what? You have two circles equations. You need to find where they intersect. That's what you're looking for. The point of intersection of these, the center of the circle we're working with, along with the circle with this center and the given distance of 5 minus root 3. If we can find that, we know it exists. Let's see if we can find it really quick. So if you take the y squared and solve for it, why y squared? Because it's by itself. Kind of nice, right? So if you do that, you'll get 9 minus x squared. Go ahead and expand this. X squared minus 10x plus 25 plus 9 minus x squared. Cancel your x squareds. You've got 34 minus 10x, and it's going to equal 28 minus 10 rad 3. Now, I like my 10x value to be positive. I'm going to move it over there. So you're going to get 10x equals, and I'm going to move these over here. Again, this is 34 minus 28 is 6. 6 plus 10 rad 3. Divide by 10. Let's see what our x value is and see if it's logically consistent with what we show over here, approximately. Okay, so 6 plus 10 rad 3. What does this represent? It represents the x value of the center of such a circle that will be the right distance away from this and that. So what is its approximate value? Again, using 1.7, this is about 17, and 6 is 23 divided by 10, approximately 2.3. Where are we at? Just beyond 2. Right about in there is right where we think it would be, and that's exactly where it shows up. Yeah, and you'll probably get another one going the other way as well. I'd have to think about what that would look like. We should get 2. So, because you should get another one up above as well, but the same spot. It would just be basically the reflection up here. So yeah, that's going to be it for this problem. I will try to film more. I'm going to try to be more consistent now going forward, that I have my little break there, had the holidays and all that. I hope you all had a happy new year, a great Christmas season and all that, and I will see you in the next problem.